Hi everyone, welcome to the Sentis sample tutorial, a video series in which we will go over a few gameplay ideas and coding samples to teach you how to best use real-time neural network inferencing inside of Unity using Sentis. So this tutorial is based on a pretty cool gameplay idea where the player is stuck in a room and to escape they will need to draw in a code. So this is my level in Unity. You have a door that's presently closed. The player then needs to analyze some clues scattered across the room and figure out what the secret code is. In this case, it's the first level, so it's pretty easy. The code is scribbled on the wall. It's 301. Once the player thinks they have figured out what the code is, they will sketch that on the code pad, and if it matches, they can progress to the next level. The first one is super easy. The code is scribbled on the wall. The player draws it on the code pad, then progresses to this room. This room is a little bit more dynamic, where the code is underneath some rigid body the player needs to push around. And then the final room is this one, which requires a little bit of counting. We have some fruits on the wall, which maps to different paintings. The player then needs to count how many fruits there are on this painting to progress to the end of the level. So for this example, we use the MNIST model that we downloaded from the Onyx Model Zoo. This model analyzes a 28 by 28 texture and outputs which digit is the most likely. So you can see it here. The model is called MNIST 12. It operates on a tensor which has a one channel. So this is like a grayscale image of height 28 and width 28 and outputs 10 values. In this case, this model outputs the probability that a sketch corresponds to this digit. Alright, so without further ado, let's jump into play mode and try it out. So I'm in the first room. The code is scribbled on the wall, 430. I go to the code pad, 430. Awesome. So now I can progress to the next level. So this is a core gameplay feature that I need to implement in C#. The player draws on the code pad, and if it matches the digit of the code, I can open the door and the player can progress to the next level. So the difficult part here is how do I go from a sketch of the 6 to the actual digit 6? How do I know that this image of a 6 maps to this digit? And actually this problem is notoriously hard and is impossible to solve with traditional coding paradigm. The way out is to use a neural network and to train the network on a number of images of digits. And you train it, and the network is able to classify those images, and on top of that is able to generalize, and when you give it the player sketch, it will be able to figure out which digit the player drew. In our case, we're pretty lucky because that problem has been tackled many times, and there's a few tutorials online. You can train it yourself. Or in our case, we're going to download a pre-trained model, and at runtime, what we're going to do, we're going to take the sketch the player drew on the screen, feed that to the neural network, which is going to analyze that sketch and determine which is a drawn digit. Alright, so now going back to Unity. The player draws on the screen. That will draw into a texture 2D. I will take that texture 2D. I will pass it to the downloaded model. Using Sentis, I can perform inference at runtime and figure out what digit it is. Once I figured out what digit it is, I can then feed that back into my gameplay loop and progress the level. So this was a pretty, easy level where the handwritten digit was on the wall, and it's pretty easy. But now that I have this tool that can analyze a sketch and figure out what the digit is, now I can vary my gameplay and make it more difficult. And all of a sudden, I've got a really cool game that is unlocked with the fact that I can perform a very difficult task using a network. And that's a core feature of Sentis is you've got some tasks that are really difficult to hand code and write in C# or any language, which are solved by neural network learning a database and performing that inference at runtime. And that ability unlocks a number of gameplay features and a number of ideas that you couldn't do before. Alright, so this is the repo. There are a number of C# files in there, so they go from handling the game logic, the panel logic, the player movement. But the one that is of interest in this tutorial is the one called MNIST engine. So this file is the script responsible for doing the inference on the sketch and figuring out which digit the player wrote. So the most important function is this one. It's called get most likely digit probability. It takes in the texture 2D where the player drew the digit, and then calls the neural network, and using Sentis performs the inference. So the first thing you do is you take in the texture and you convert that to a tensor. So in this case, we convert to a tensor which has width W, height W, and channel 1. So it's like a grayscale image, and we're gonna the image is RGB, and then we're gonna transform that into a tensor of one channel, one color channel. Then once we have that, we're gonna center the image. The reason for that is the network has been trained on centered image. So if the image is not centered, the network is not going to be able to perform efficiently. It's still going to work, but it works better if the digit is centered in the center of the image. So what we do for that is we figure out the bounds of where the player drew, and clip the input tensor to those bounds. Then once we've got that clipped image, we're going to pass that into our neural engine. We're going to execute. That neural engine was created here on the start method, and it takes in a backend type, which is either the CPU or the GPU, and takes in a model. Your model is your Onyx file that you've downloaded and imported in Unity. Then you take the engine, you execute it on the input tensor, and then the result, you're going to use peak output to get the result of the inference. So what this model gives you, it gives you for each digit the probability that the digit the player wrote is that digit. So in this case, it's going to be a 1D tensor of 10 elements. And on the first element is the probability that the player drew a 0. And on the 7th index is the probability that the player drew an 8. So the thing is we need to normalize those probability between 0 and 1, and what we do is we use a softmax function. So in Sentis, the cool thing is you can perform that with something we call the ops. And it's called, we create it on start. We use a worker factory create ops, and that will create you like a GPU op that you can perform operation on tensors efficiently on the GPU. You can use a CPU one. In this case, it will run burst and do the inference for you. So in this case, we calculate softmax as just normalizes the probability between 0 and 1. So now we have the probability, so we could just use that, right? But what we want is we want the index of the highest probability. So that, we could take a list and loop over that, but it turns out that we've coded that for you, and it's called the argmax function. So you take the argmax, and what that does, it gives you the index of the maximum element in it, which is what we want. And you pass it in the tensor of the normalized probabilities, and you say, okay, compute me on the last axis. This is where there you have the 10 digit, and you perform the argmax on that, and that gives you the index of the max probability. Then now we have the probability and the index, and we can get the predicted number, which is just the index. And we can return that, and in our code we can detect what digit the player wrote, and we can either open the door, close the door, ring the alarm, and so on and so forth. All right, I thought I'd finish with a few gotchas. So the first one is remember to read the documentation. So that is really important. So I know it's tempting to jump right in, but spending a few minutes to understand the API and what it does will save you a lot of trouble down the road. If you have any question that the documentation doesn't address, you can always ask on the forums, and we'll be there to answer you. The second one is to know your model, especially your inputs and outputs. This model we played around with only works on images of size 28 to 28. But some other models can be trained with images that are bigger, like 256 by 256. Some networks are trained, the pixels needs to be in a range of 0 to 255, or some is normalized between 0 and 1. It can be in another space, maybe it operates on RGB or grayscale, so you got to know your inputs. Your outputs is also equally important. Like this network only gave us the probabilities of each digit, but some models might output the digit itself. So it's really important to know your inputs and outputs. The fourth point is to not make the model work too hard. So models can get pretty big, pretty fast. And you might be tempted to run inference every frame on everything. But, networks are very powerful, but you got to tune them to a very specific task, and you got to use it only for the hard problems. Some problems can be solved with other means, with, faster math or just like coding it. In this case, don't use a network there, and really save the inference time for very difficult tasks like the digit recognition that you can't solve otherwise. Of course, you also gotta to know and work with the limitations. Some model might be too heavy for your platform, and you might not be to do like the full inference at once. In this case, we might want to split inference over a few frames, or maybe split it, give the work to the GPU to do the inference. So you really got to know the limitation of your model, the limitation of your hardware, and to tune your game accordingly.